Okay guys, so today we went over the Meselson and Stahl experiment in class, and I just want to recap what we went over. So at the time, Watson and Crick had just discovered the structure of DNA. And the next question that they wanted to ask was, well, how does DNA replicate itself? How does it make a copy? And so there were three prominent ideas there being circulated. So there was the semi-conservative, where DNA literally, you have a copy of your DNA, like this, your double helix, and it somehow gets split in half, and that each one of these copies ends up being made, a copy is being made of it. And so that was one theory. The other theory is that the conservative theory, where basically you have your DNA and that DNA is wrapped around your histone complex, and so you have this DNA that's wrapped around the histone, and as the DNA unwinds, so if this is your DNA, as it unwinds, it allows itself somehow to be copied. Both strands are copied, and so you get two copies. You get your DNA copied as it unwinds, and then it refolds back. And so what you would end up with is your copied strand of DNA, the new one, and then you would end up with your original strand of DNA. So your parent strand of DNA would remain the same. So you would have a parent strand, and then you would have your copy. And both in your copy strand, you would have two new pieces of DNA, and in your parent strand, you would have the original pieces of DNA, or the original DNA. So, and then the other theory out there at the time was that you have this DNA, and the DNA, this double helix, gets chopped up into pieces. And when it's chopped up, you have new pieces being copied here, and then they all get put back together sort of indiscriminately, and so you have some new and some old pieces, which you see here. You have some old pieces, and then you have new pieces added and old pieces. And here you have some new pieces, old pieces, and new pieces. And so this was the dispersive idea. So what Meselson and Stahl basically did is they wanted to come and design an experiment to see which one of these, was it the semi-conservative, was it the conservative, or was it the dispersal? Which one of these theories was the way DNA replicated? And it's called the most eloquent experiment because it is truly a beautifully designed experiment. And so in order for this experiment to happen, they took their DNA, and remember DNA has those nitrogenous bases on it. Well, the fact that they have the word nitrogenous should tell you that it has a lot of nitrogen in it. And they took bacteria that had DNA. You can see the DNA in the bacteria. They took these bacteria and they gave them food, and that food is the name of the food that you feed them is the media. They gave them media, and that's just the food that the bacteria eat, all the nutrients. And they put in an N15, a nitrogen 15, which is a heavy nitrogen, because normally nitrogen is an N14. And so what I mean by that is the N15 heavy nitrogen has one extra neutron, and that makes it just a little bit heavier. So they grew the bacteria colonies in this N15 media with the heavier nitrogen. And so when the bacteria made its DNA, the DNA, because it had so much nitrogen in it, became much heavier than a DNA that would be grown normally. So they did this over many generations until they got pretty much basically all of these colonies with DNA that had two strands of N15 nitrogen DNA. So this is heavy DNA, the two parent strands. So they then took their bacterial colonies and they transferred them into media that was normal nitrogen. And they took out samples. They took out the 0 starting sample. They took out a sample at 20 minutes, 40 minutes. They took out a sample at 60 minutes. And they probably took out a sample at 80 minutes. They took out the sample. They extracted the DNA just like you guys extracted your DNA in class. And then they centrifuged it on a cesium chloride gradient. And the reason why that's important is because cesium chloride, number one, is a salt. And when you put DNA in a salt, it's going to stay together. It's going to stay bunched up. It's not going to break apart. Number two, cesium chloride is a salt that if you put it in a centrifuge, that means you're spinning it around and around and around pretty fast. The cesium breaks away from the chloride just a little bit, and so it does it a little at a time, so it creates a gradient of salt, this cesium chloride salt, and so it's lighter at the top, and it gets heavier and heavier and heavier and heavier as you go towards the bottom. And when you put your DNA in there, the DNA will find wherever it's, if this is the DNA's weight, right here, the DNA will stop. It won't keep going any further down because this is heavier, and so this will centrifuge down. The DNA will stop here. If the DNA is really heavy, maybe it'll stop here, maybe it'll stop here. But the reason why that concentration gradient is so important is because the DNA will stop in the salt, this salt solution, where the salt solution, the cesium chloride, is the same weight as that DNA. So when they spun it down, they took their unlabeled DNA, and that's going to be their negative control right here. And so that has no N15, but rather all N14. So they took the normal bacteria DNA, they used that as their negative control. And when they spun it in the gradient, that N15 DNA is located at the top. That N14 DNA. So the normal DNA is light and it's at the top. Then they took their positive control, and this is their parent DNA. And what do I mean by that? I mean, this is the DNA they grew here on this N15 plate. So that's their parent DNA. All it's been exposed to is N15 media. And they extracted the DNA and they spun it, and look what they found. The DNA is much heavier, and so it's towards the bottom of the cesium chloride gradient. Then, after 20 minutes of growing on this N14 media, they took these colonies and they extracted the DNA and they spun it in the cesium chloride gradient. And what did they find? They found that that the DNA was not at the bottom here. It wasn't here, but it wasn't at the top here. It wasn't at the top either. It was in the middle. And that told them that they had a mix. This DNA was a mix of both the N14 and the N15. Now they took another sample at 40 minutes, and what they found is they still had this mix of N14 and N15, but they also had just this N14, this lighter band up here of DNA. So let's have a look. So this was the F1 generation. The F1 generation here. Whoops-a-daisy, undo that. So let me just put F1 generation. And it's the hybrid generation. So it's half heavy, half light. And F2 generation. And if we look here, what we see is that's what, if it were a semi-conservative model, that's exactly what we would see. This is my parent generation. And so this was all N15, and it's heavy. That's what we saw right here. Parent generation right here. Right here. This is my parent generation. Everything is heavy. When I come in and I split this parent generation to copy itself, I break those hydrogen bonds here. Helicase comes in and breaks it up. I have one parent strand here and one parent strand here. And then I make a copy of that parent strand. And so I have my parent strand, and then I have a new copy. And I have my parent, and then I have the new copy. So I have a hybrid. And that's exactly what they got here. They got a hybrid. They have the parent strand here, the heavy one, and a new copy here. So they have a hybrid of both. So then, for the next generation, so this was my F1 generation, 20 minutes. And here, for the next generation, the F2 generation, 40 minutes. You have this parent strand here. Remember, this gets split apart again. Helicase comes in and breaks it apart. Parent strand here. New DNA is made here. And then this becomes my parent strand here. And then this one is my new DNA here. And that's same on this side. Parent strand here, parent strand here, and my new here, new DNA on this side and on this side. And then again, you'll see when you split apart the DNA again, parent strand here, and then another parent strand here. Here's my copy. So that's my new, and here's my new. I'm just looking to see where that's. This one on this side is my new. So you can see parent strand, new DNA here, new DNA here, parent strand, new DNA, new DNA. So you can see this would be my F3 generation. This would be after approximately 60 minutes. And I don't think we have the F3 in the tube, but what we do have is you can see that if I look here, this would be my F3 generation, where instead of having 50-50, where I have half of my DNA is the N14 and the other half is the N15 for my F2 generation, which is what we have right here after 40 minutes. I am now having 3/4 of my DNA is this N14 not heavy, and only 25% is this hybrid here of N14, N15. And that's exactly what you're seeing here. Yep. That's for your F2, and this is what you're seeing here. This is that 75% is N14, and then 25% is N15, N14 hybrid. Yep. So by doing this beautiful experiment, they proved that DNA is replicated by the theory number 1, which is semi-conservative. Hope that was helpful.